Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to look at the purpose of access control lists. We'll be discussing what is an ACL, packet filtering, and then finally access control list operation. This episode is part of my series on enterprise networking, security, and automation. I'm Kevin here at KevTechify. Let's get this adventure started. An access control list, typically is referred to as an ACL, is a series of commands that filter out packets as they go through a layer 3 router. It's looking at that packet, it's looking at the header of that packet, getting the information out of the header of that packet, and then looking for entries here in this access control list to either allow, permit, or stop it, deny that traffic from going through the router. Now, when you first start with a router, it doesn't have an access control list on it. It will allow all traffic through all the interfaces that you go through, configure, and set up. These ACLs you're going to create, they get applied to an interface. Each interface can have the access control list applied to it. Depending upon your scenario, you may apply an ACL to one interface, but not to the other interfaces. The router itself, this is an additional task. Besides evaluating the packets, deciding on the routing, which way to send it, we also determine if we're going to send it on or stop it, allow it to go, permit it, or stop it, deny it. Now, this list is a sequential list of either permit or deny statements. Each one of these statements in there is known as an ACE, or an access control entry. Now, these access control entries, they're also known as ACL statements. A whole bunch of statements make up one list. As traffic passes through an interface, the router compares the information within the packet, specifically in the header, against each access control entry. It goes through that list. It starts at the top. It works its way down. It compares one. If it doesn't match that, it compares the next one and compares the next one. It goes through in sequential order. If that packet matches that access control entry, then we do what that access control entry says. Permit, deny, permit it, allow it to go through, deny it, we stop it, we discard it. This is what we call packet filtering. There are several things an ACL does. First thing it does is it limits the network traffic. By limiting our network traffic, we can increase network performance. A lot of times your traffic on your network doesn't have to travel to all parts of it. It just needs to go to its destination. And by allowing it only to go to its destination and not the other parts, you're eliminating a lot of unnecessary traffic on your network. We can provide traffic flow. How do we do that? Well, what we can do is on these different routers with the interfaces, we can say no video through here. Right here, this access control list says no video down through here. Now, this could be maybe publicly accessible computers. You don't want people watching Netflix during work hours. That would probably be a good example of what we can do there. Then the idea of ACLs is a basic level of security. So first one we had was limit. Then we have traffic flow. So we're looking at traffic flow. Next one is limited security. And what we mean by limited security is we can allow certain things to go through and certain things not to. Up here on our router, there's an ACL that's on the interface that connects to the internet. What we can do is we can allow email to come in because our company works on email. If we don't get our email, we can't make money for the company, but we don't allow Telnet to come in. We don't allow Telnet, and that's applied there. Why don't we let Telnet? Two reasons. One is people shouldn't really be telnetting into my network. And two, Even if it's an employee that's telnetting in, you shouldn't use telnet because it's clear text. It's unsafe. You should be using SSH. And what we can do here is limited security. We're securing our network by not letting telnet on our network. The next thing we can do is filter based on traffic type. So we can filter traffic type. And that would be this example up here. We are allowing email to come in and denying telnet. And so it's not necessarily where the traffic's coming from or where it's going, but we're just going to say if it's email, you can come in. If it's telnet, we're just going to stop you. The next one is the screen hosts, or we screen host to permit or deny access traffic. So we can look at this and say certain hosts can go onto our network, certain hosts can't. Now, what we can do here is either identify a specific host or we can identify a range of hosts, and that range would be like a network address. And so we can look at the hosts there. And then the last one here is we can provide priority to certain classes of traffic. Now, why would we want to provide priority? And I'll write it down here. Provide priority. You want your real-time traffic to get through your network faster, right? The streaming video, the streaming voice, you want to get through your network faster than traffic that isn't necessarily time dependent. If it takes a little bit longer for that web page to load in, that's fine. But if your phone voice over IP phone conversation is broken up because there was other traffic that had to make it through there, that's going to be disruptive to that phone conversation. So we're going to let real-time traffic go through our devices first, hold back the other ones. Now, when we say hold back, we're not talking 3 seconds, 10 seconds. We're talking milliseconds. Maybe a handful of milliseconds, 3 milliseconds, 10 milliseconds. To the end user looking at that web page, are they really going to know that their traffic was 10 milliseconds slower? Probably not. If you like this episode on the purpose of access control lists and you get value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website for all of my details and how to get these episodes in video and podcast form. When we look at packet filtering, we can do packet filtering at layer 3 of the OSI model and layer 4. Layer 3 is the network layer that deals with the IP addresses. Layer 4, the transport layer, that deals with those logical port numbers, like port 80 is for web traffic. As we go through and set up our list, there's 2 types of access control lists. There's a standard one and then there's an extended one. The standard ACL only filters on layer 3, specifically on the source IP of the packet. And a standard ACL will only look at the source IP address of that layer 3 packet in the header. It won't look at any other information. An extended ACL gives you a finer control. Not only will extended ACLs look at the IP address in the header, it will look at the source and it will look at the destination IP addresses. And it can filter on either one of those, the source IP address in that packet header or the destination. The other thing an extended ACL does is not only looking at layer 3, it will look at layer 4. It will look at those port numbers. It'll look at TCP. It'll look at UDP. And then it'll look at the layer 4 port numbers. And once again, layer 4 port number example, port 80 is HTTP. We can filter on all that type of information to give us a better granular control of what we are filtering. ACLs are a set of rules that give added control for packets that enter the router, go through the router, and then leave the router. We can look at traffic at all those points. What we can, and how we do that, is we look at traffic coming into the router, and we can apply a access control list there, and we can look at the traffic leaving a router. We can apply an access control list there. An inbound ACL filters traffic before it's routed. When normally without the ACL, traffic comes into the interface, goes into the router, we process it through the routing tables, and then we send it out an interface. But when we put an inbound ACL, it has to go through that ACL first. It has to be permitted to go through that ACL. Then it'll go to the router, and then the router can do its routing functions and then send it on its way. An outbound ACL, the traffic comes into the router routes it, so it comes in one interface, goes through the routing table, finds a match, the default route, and then it goes out the interface. But right before it goes out the interface, that's when that outbound ACL, that outbound filtering is going to happen. Now, an inbound ACL is more efficient because it saves the overhead of having to go through that routing table. When the traffic comes in, it's then filtered by the ACL. If it doesn't meet the criteria to go through that ACL, it's discarded. If it's an outbound filter, it has to come into the router. Every piece gets processed, and then only the stuff that makes it through the list goes to the outbound ACL. The other thing to notice is if the traffic actually starts on the router itself. It starts here. So it's maybe part of a routing protocol. Maybe it's part of CDP where it's communicating with other devices. If it starts on the router, ACLs will not be applied to it. Inbound, outbound ACLs, it will not be applied to it. So if that traffic originates on the router, ACLs will not be applied to it. How an ACL operates depends upon if it's an inbound or outbound ACL. For this example right here, we are looking at an inbound ACL. And so the traffic is coming in from our network. This is our network here. Traffic is coming in to our router. It goes through this process, comes down here, and then it's sent to the routing table at the bottom. What happens here is this is the routing here. This is where routing actually happens. And so the device made it through this list and it went there. Now, when this packet comes in from the network and there's an inbound ACL on that interface, it's going to go through each one of those access control entries, each one of those rules, and compare it. Does it match this? Now, if it's a standard one, we're just looking at source IP address. If it's extended, we can look at source or destination IP address. We can look at CD or TCP, UDP. We can look at that layer 4 logical port number. And we can go through and we process this first access control entry. When something matches that first ACE, that access control entry, either in the layer 3 IP address or the layer 4 information, if it's matched, what it does is it comes down here and then it goes and it looks at the rest of that access control entry. If that access control entry says deny, if it says it's a deny statement, what we're going to do is we're going to deny it, we're going to send it out, and then we're going to discard it. We're going to discard it. But if it matches, if it's permitted, we're going to send it into our router and send it to the routing table so then it can be processed. But up here on this first ACE, if it doesn't match the criteria, layer 3, layer 4, we're going to go on to the second one. It doesn't match anything. We're going to go on to the second one. On the second one, we're going to go through and process it. If it matches the criteria, we'll come down and say either it's a permit or deny. But if it doesn't match that one, we go on to the second or third one. We look at the third one. And then we go through all of the aces here. We go through the 4th one, the 5th one, the 6th one. We go all the way up to the 100th one. If they match, it'll come down here, and then it's either permitted or denied. If it's not permitted or denied, or if it doesn't match, finally, at the end of an ACL, at the very end of the ACL, we deny everything. There's a implicit deny. And you don't have to type that in. It's automatically put it in there. The iOS puts it in there for you. And you can think of this as we start processing through all of our access control entries. We do the first one, the second one, the third one. If there's no matches, we get down to the end. At the end, because there was nothing that matched and nothing that permitted, we then say, okay, we don't trust this data, basically. We're going to deny it. And so if it doesn't match any of our ACEs here, our access control entries, we go to that implicit deny right here. That implicit deny is an automatic discard of our packet. Once again, notice all of this decision right up through here, everything on this side of the line is done before it comes in to the routing table. Okay, that's the inbound ACL. The outbound ACL, this one here is an outbound. Notice how it's a little bit different. Right here at the top, we're from the routing table. Basically, you can think up here, this is the routing here. Our routing started here. Then it's passed off to an interface. The routing has decided it's going to a certain interface. Before it's sent to that interface, though, we have to make it through our ACL. And in our ACL, we have a bunch of ACEs, access control entries, and we go in there and we process them in sequential order again. We look at the first one here. Does it match our criteria? If it's a standard one, do we match that source IP address, where it came from? If it's an extended, we can match source IP, destination IP, TCP, UDP, layer 4 port numbers. We can match all that. If it matches that criteria, then we come down and process the rest of that ACE. Was it a permit or deny? If it's a deny, we can go over here to our discard. So it was denied here. It goes over and is discarded, dropped, deleted, doesn't go through there. For some reason, we stopped that traffic. That was stopping that telnet traffic from coming in from the internet. But if it's permitted, then when it's permitted, we can go this way, and then we actually send it to the interface. It actually goes to the interface and is sent across the network to the next routing device or to the switch to be delivered to its final destination. Every ACL goes through this process. So we went through, we compared here with the ACE, it matched, we went down as permit or deny, but if it didn't match, then we go on to the second ACE. We go through and we look at the layer 3, layer 4 information again. Does it match? Does it not? If it matches, we come down to the permit or deny. If it doesn't, we go over to our third ACE. Same thing. If it matches the layer 3, layer 4 information, we send down permit or deny. Then from the third one, we go to the fourth one, fifth one, sixth one, seventh, on, all the way up to the 200th ACL. But when we eventually get to the end of all those access control entries, and it hasn't matched any permit, it then goes to our implicit deny. Here's our implicit deny. It didn't match anything previously to get sent down here. Finally, we're at the end of our ACEs. We reach this implicit deny. We're just going to deny everything. Once it hits that statement, it is then discarded. It was my pleasure to bring you this wonderful episode on the purpose of access control list. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.